So this, I already forgot. It was on what page? 37. So this is going on page 37 when we're done. And I know this is pink and it's probably harder to see, but let me know if I use a color you can't really see. So this is symmetry, but just with functions, okay? And it's the even and odd functions, which means which type of symmetry are we not going to care about? Well, look at the ones we did yesterday. The ones with the origin symmetry, were they functions? Maybe not all of them. It is possible to have origin symmetry and not be a function, because like the circle, right? But look at example 1. Is example 1 from yesterday, is that a function? Yes. The y-axis symmetry, was that a function? If that's all it has? Like a parabola? Mm-hmm. It's the x-axis symmetry. Because if it has x-axis symmetry, it's going to fail the vertical line test, right? So we don't care about x-axis symmetry right now. We're looking at even and odd functions, okay? And so a function is even if for every number x in its domain, the number x, negative x is also in the domain, and f of negative x equals f of x. So this is what we're going to be checking for. If f of negative x equals f of x, then it's an even function, okay? And an even function is symmetrical to the y-axis. So visually, if it has y-axis symmetry, it is an even function. And that's the one thing that we did look at in geometry. And that's all we did, was just look at it, because we weren't ready to start plugging stuff in and look at the functions, but just, hey, we were talking about symmetry, we were talking about reflections, we can look at y-axis symmetry, we know it's even. Okay, but now we also have to look at it algebraically. If we don't have a graph, or if we do and we need to prove it, that sort of thing. So then we have odd functions. A function is odd if for every number x in its domain, the number negative x is also in the domain. And f of negative x equals negative f of x. An odd function is symmetrical to the origin. So these two things right here are what we are checking for. But there's really just one test. And once you're done with that one test, you see what happens, okay? So we do have graphs on a couple of them, so you can make your assumptions visually, but then we also have to do the algebraic test that goes along with it, okay? So let's look at this first one. What kind of symmetry does this first example have? Y-axis symmetry. Okay, so we assume it is what kind of function? Even function, okay? Even with the y-axis would be an even function, but we have to test it. So to test it, whether you think it's even or odd, you plug in negative x. Okay, so you find f of negative x. And I plug in negative x for all the x's. So this is going to give me negative x squared minus 5, which means f of negative x equals what? X squared minus 5. Okay, so look at f of x and look at f of negative x. Are they the same? They're the same, right? So then we can say, since f of x, or f of negative x, equals f of x, algebraically, since those two things are the same, that's what makes this an even function. Okay? So this is like your proof, like your work, and then this is your kind of explanation. Since this happens, this is true. Okay? Easy enough? All right. So now let's look at this next one. What kind of symmetry does it look like it has? Origin. So looks like it has origin symmetry, and that would mean that it would be even or odd? Odd. Odd, O for origin. Think about it that way. And so f of negative x, we plug it in. We're going to get 5 times negative x cubed minus a negative x. So f of negative x equals, what's negative x cubed? Negative x. This is going to give me negative 5 x cubed, and then minus a negative x is plus x. So at this point, I look at f of x and f of negative x. Are they equal to each other? No, they're not. So I got to do one more step then. I'm going to factor out a negative 1. So f of negative x equals, factor out a negative 1. That would leave me with 5x cubed minus x. So since this didn't work, now I'm going to look at f of x and f of negative x. Is this negative f of x? Is what I have in my parentheses f of x? So this whole thing then here is just the negative of whatever f of x is. Does that make sense? So since that is true, then I can say that f of negative x equals f of x, negative f of x. And since f of x equals negative f of x, what type of function is it? Odd. Okay, everybody good with that? So if you end up with the exact same thing, it's automatically even. Then you factor out a negative 1, and then if what you have in parentheses is f of x, what you have is negative f of x, so then that makes it an odd function. Easy enough? Questions about that? All right, so let's look at the next one. Does this graph have symmetry? It does. Does it look like it has y-axis or origin symmetry? Okay, maybe origin. Okay, so we're going to check it anyway. So we plug in, and we get f of negative x equals negative x cubed minus 1. So f of negative x equals negative x cubed minus 1. Right? So after I've plugged in my negative x and just simplified a little, as much as I can simplify at this point, then I look at f of x and f of negative x. Are they the same? No, they are not. So then I factor out a negative 1. F of negative x equals negative 1 times x cubed plus 1. So now I look at f of x and what's in the parentheses here. Are they the same? No, right? So f of negative x doesn't equal f of x. It also doesn't equal negative f of x. So is this an even or odd function? No, it is not. So I can say over here then that f of negative x does not equal f of x. F of negative x does not equal negative f of x. That's what makes it neither. And this, because this point, see, it does have symmetry. It has rotational symmetry right about this point right here, but that point isn't the origin because it has a vertical shift. Okay, we good? Questions? All right, why don't you work on this one? You don't even have a picture, so you can't even take a guess at the beginning. And if you need to, since there's no picture over here, if you need more room to work, you can work over here, like start here and then work over here if you need to. Going to start working this and see how far y'all got. So I'm plugging my negative x. This gives me negative x cubed over 3 times negative x squared minus 9. Okay, so negative x cubed is negative x, and then I have to change the sign on it. So f of negative x would equal x cubed over negative x squared is x squared. So this is 3x squared minus 9. Okay, so I stop and look. Does f of x equal f of negative x? No, it does not, right? So then I got to keep going. I'm going to factor out my negative 1. So f of negative x equals negative 1 times. Okay, that means that I could do that a couple of different ways, but if I factor out a negative 1 from the numerator, what does that give me? Negative x cubed. Would I also do that to the denominator? No, right? You don't do it to the numerator and the denominator. So this would be 3x squared minus 9. Oops, I don't need those ones. Like so. Because if I multiply a negative 1 times this fraction, I wouldn't multiply everything in the numerator and everything in the denominator, right? I pick one or I stick it out front. So now when I look at this, does what's in parentheses match my f of x? It does, right? So f of x does not, or f of negative x does not equal f of x, but f of negative x does equal negative f of x, right? Fractions. We have to learn to love fractions. So what kind of function is this? Okay, questions about that? All right, let's go back up to the top because something bothered me with this when I read it. Okay, so it says a function is even if for every x in its domain, the number negative x is also in the domain. Okay, so that's a true statement. For every x, there has to be a negative x, right? For odd, even that, for every x, there has to be a negative x, but that essentially is saying the exact same thing, isn't it? I mean, if you read those sentences, it's like it's saying the exact same thing, which doesn't make sense to justify the difference between the two. So I want to change that to ordered pairs. So if it's an even function, for every xy, what would the ordered pair that matches it have to be? Because negative xy. Because that's a reflection in the y-axis, so you change the sign on x, right? That's why it's the same thing you rewrote 1,000 times yesterday when you had to do it on your homework, right? It's the same idea. So the sentences are not wrong. They are true statements. It's just not the full extent of what should be happening here. So if it's odd, for every xy in its domain, what has to match up with it? If it has origin symmetry, what is negative x, negative y? So yeah, they both have negative x's in them, but on the odd, it's the negative y also to kind of finish that up. Questions about that? So can you tell by looking visually if it's even or odd or neither? You can look and do that, right? And then do you understand how to plug it in and check? And these are the two things here that you are looking for. Okay? Are we all good? Awesome. All right, so you're going to have to like fold that in half to glue it in on page 37. And then on the outside of it, maybe write even and odd so you know what's even there.